staying safe and having a good day. So let us go to the fifth lecture of this series of interview questions. And this series will be having questions about stress strain curve. So I'm pretty sure no matter what exam you're going to give, there'll be at least one question from this topic. So let's get started.
And before we start, I would really appreciate it if you could smash that like button, drop me a comment, and share this free program with anyone who might need it.
Before we go into the questions, let us understand what is a stress strain curve. So stress strain curve is where we'll plot the stress in the y-axis and strain in the x-axis. So why do we plot the stress strain curve? Mainly is to understand the property of the material, and next is to find the ultimate strength, yield point, elastic properties, etc. So all these things we can be found using the stress strain curve, and it is also a very easy topic. So let's get started. First one is the stress strain diagram for a rigid material. So before going to that, I want you to remember one thing. So stress is the input you are giving to any material, and strain is the output because of this input. It is the reaction to stress. I want you to remember when I say strain, I want you to remember elongation. However, strain can be both elongation and compression. But for simplicity, I want you to imagine when I say strain as elongation. So going to the question, the stress strain curve for a rigid material. So we know what is a rigid material, though it does not exist. We will assume that no matter what stress that we are giving, it will not change its dimension at all. It will not elongate, it will not compress anything. So keeping the previous slide in mind, so this is my stress, this is my strain. So I know that for a rigid material, my strain is 0. That is, there is going to be no elongation at all. My strain is going to be 0. So no matter what stress I am applying, the stress can be from here to 0, say it is 100 here. No matter what stress I am applying, my strain is always going to be 0. So the curve for a rigid material will be something like this. It will not be a curve at all. Going to the next question, the stress strain curve for fluid material. So this is the opposite. Even without any stress being applied, the strain will increase here. So if you look at the stress strain curve, this is my stress, this is strain. So it will be something like this, opposite of the rigid material. Going to the next question, the stress strain curve for a plastic material. So now plastic material means I want you to keep in mind this diagram. So in reality for a plastic material it will be something like this, but this diagram it represents an ideal plastic material. So what happens here is at the starting for every increase in stress there is increase in strain, and after that even for a small increase in stress, that is after it has reached the yield point, even for small increase in stress there is considerable amount of strain. Going to the next question, the stress strain diagram for a brittle material. So when I say brittle, I want you to remember concrete. In brittle material, it doesn't have any elastic properties. For every stress, increase in stress, it increases, and after it reaches the elastic point or elastic limit, it fails. So this is the stress strain curve for a brittle material. It will just increase and it will fail. Then you can see that in this diagram for stress and strain for a brittle material, it increases and breaks at a point, that is it fails here. But whereas if you look at a ductile material, by ductile material I mean H by SD bars or mild steel. So this point is here. So from this we can understand that even after this point there has been a considerable increase in stress here. So if we look at the diagram of a ductile material, you can see that the stress strain curve is linear up to a point, and that point is called as the proportional limit. Next is the elastic limit. So elastic limit is the point up to which if my load is removed, material will be able to come back to its original shape. Next is yield point, where it starts to yield, and after the yield point we can see that there is a considerable increase in stress. Even after the yield point it is able to take stress. So this part is what we called as strain hardening. We'll see about it in the upcoming slides. And here this is my ultimate strength. But even after my ultimate strength, my structure will be able to take even more load before it fails. But in reality, for design purposes, for safety reasons, we will assume that after the ultimate strength, the strength of the material reduces and it reaches the rupture strength. So going to the next question, the stress strain diagram for aggregate. So what is aggregate? Aggregate, I need you to understand the property of aggregate. Aggregate is a brittle material. It can take large amount of stress, but it does not have any elastic properties. It cannot yield like a steel. It cannot yield. So this is somewhat equal to the rigid material that we saw earlier. Since it is a naturally occurring material, it will be very strong than man-made material. So looking into the stress strain diagram, it will be something like this. If my rigid material is something like this, then my stress strain diagram for aggregate will be like this. This is my stress. So it will be able to take more amount of stress, but it will not be able to elongate. So let's look into all the things: cement, paste, and concrete. So if it is cement paste. For in cement paste we have cement. So cement, it has elastic properties. It is able to yield. At the same time, it can also take stress also. So if we look at the the stress strain curve of cement, it will be something like this and fails. So if you look at concrete, let us look into this diagram here. So we have seen here aggregate, it is something like this, very negligible amount of strain only. But when you look at cement paste, it can take large amount of strain. The stress taken by cement paste is less than the aggregate. And when we come to this point, when we come to aggregate, which is a combination of both cement paste and aggregate, we can see that it is an intermediate of both aggregate and cement paste. And unlike aggregate and cement paste, where there is a linear behavior between the materials till the yield point, in concrete we don't have any such behavior. The reason is because we have already seen in the previous videos. The reason is because of ITZ, and because of this interfacial transition zone, the micro cracks occur in the concrete even before it is loaded. Since the micro cracks occur, we cannot take the behavior into a linear way. Therefore, we can see that the stress strain curve for concrete, it is non-linear, and also the stress taken by concrete before failure is also less. Going to the next question, the stress strain curve for elastoplastic material. So the answer is something like this. We'll look into this more in when we look at steel structures. So previous one of the questions we saw what it is for a plastic material, that is an ideally plastic material. It was something like this. For an elastoplastic material, the elastic part is it is prominent. We can see that there is a linear elastic part before it yields. So this is what we call as an elastoplastic material stress strain curve. Next is what is strain hardening. So yes, in the previous videos we saw what is strain hardening. Let us look into the definition. Strain hardening is when a metal is strained beyond an yield point and increasing stress is required to produce additional plastic deformation, and the metal apparently becomes stronger and more difficult to deform. It may look like Greek and Latin to you. When we look at the diagram, it will be easy to understand. So we can see that this is an if you look at here, this is my yield point, and after my yield point up to my ultimate strength, there is a part. This part is called as my strain hardening. And in this strain hardening, you can see after the yield point, in order to produce considerable amount of strain in a material, I will have to increase the stress that I am inducing on the subject. So an increasing stress is required to produce additional plastic deformation, and the metal apparently becomes stronger because it is able to elongate more, and it is also able to take more stress. So it is becoming very strong in this strain hardening region. Going to the next question, the stress strain curve for mild steel. So if we look at the stress strain curve of a mild steel bar, so at the starting it will be linear till my point. This point is called as my proportionality limit, because till here the stress strain curve is linear. After this comes my elastic point. We have already seen what is elastic limit. So till the elastic limit, if I remove my load, it will be able to come back to the original shape. After the elastic limit comes my upper yield point, lower yield point, and then a small lag, and after this comes my strain hardening till my ultimate stress. And after my ultimate strength has been reached, necking happens, and after necking the structure fails. So from the upper yield point and the lower yield point, I will be able to find my the yield strength, what we called as Fy. So for my steel bar, we know it is 250 MPa. How it is found is using the stress strain curve only. From this only we will find that Fy is equal to 250. So going to the next question, what is proof stress? So in the previous video, in the previous slide, we saw what it is for an mild steel bar. But whereas if we come for H by SD bars, it won't be prominent like this. It will be something simple. Like it will be increasing. There won't be any prominent changes here. It will just go like this. So from this diagram, we cannot be able to find what is my yield stress. That is what is my Fy value. So in order to find this, what we'll do is we'll merge this with this diagram. So now I have my mild steel diagram. If I look at my H by ST bar, so H by ST bars obviously they'll have higher strength. Therefore, it will be something like this. It will be here, and after this it will go like this. So here we know that this point occurs at a point of 0.002, also called as 0.2 percentage. That is why sometimes you'll hear the saying called 0.2 percentage proof stress. So this occurs at a strain of 0.002. The slope of this curve and this curve, it will be equal. In order to show the difference between them, I have drawn like this, but in reality the slope will be equal. So we'll have to draw a line in such a way that it has the same slope of these both lines. The point where this intersects will give us the Fy value. Going to the next and the last question, the stress strain curve of bricks. So we have seen for all materials, we have seen it for different types of materials with different properties. So from this, I want you to understand the concept and let me know what will be the type of curve for this. Take a minute or two, watch this video, think of it, and I want you to draw it in a paper beside you. And when I draw the curve, I want you to compare and see whether it is correct or not. Okay? Your time starts now. So I hope you are able to draw it. It is a very simple question. We know that the property of brick, we know it is brittle, meaning it can take large amount of stress, but it is not very elastic. It cannot elongate much. So the stress strain curve of brick will be like any other brittle material. So we have seen what is the stress strain curve for brittle materials like concrete already. So it will be something like this, just like this. You don't have to keep different stress strain curves in your mind. Just understand what is the stress strain curve for brittle material, for HYST bars, that is for elastic materials, ductile materials, plastic materials, that is enough. So from that you will be able to relate and find what is the stress strain curve for bricks. So the main idea of this video is to make you understand the concept behind the stress strain curve. I hope the purpose was served. In case you found this video helpful, please do like it, share it to your friends. And the best way to prepare for any exam or interview is to find a buddy. So find a friend with whom you can prepare for your interviews and share it to them so that you will be very focused than you were yesterday. So thank you so much for listening, guys. I'll see you in the next video. All the best for interviews. Bye bye.